tree part. And that's your fault for not coming to class. Or, I don't know.
I think we got it. That was pretty good.
Yeah, they're just trees, except they're upside down. Okay. Next, we're going to be talking about XML documents. So this is the second part of our sandwich that we're going to be making of XML trees and then, or XML and then trees. I'm going to erase this tree, if that's okay. It's kind of ugly at this point. There's a lot of drawing on it, but lots of terminology. So XML stands for, I believe, extensible markup language. That's EX, extensible markup language. And I guess that's just because XML sounds a lot cooler than EML. EML kind of sounds like email. Maybe they thought that people would get confused. Who knows? Let's double check. Yeah, extensible markup language. It is a textual document format that is used all over the web. So you can imagine when people were making the internet, they thought you can't just throw a bunch of code on the internet. I can't have my own way of describing how a web page should look. And you guys cannot each individually also have your own way of describing how a web page should look. So they created standards and different types of formats that are used all over the web. One of these is HTML, which you should have familiarity with from project number 1. Another one that we talk about is XML. So it is used to represent hierarchically organized data for ease of use by both humans and computers. Hierarchically, in this case, simply means stored in a structure that is similar to a tree. So other things that are hierarchically organized, you can think of family trees. You can think of file systems on your computer where a folder can be contained within a folder, can be contained within a folder, and then have a bunch of files in it. You can think of hierarchies in like Britain. I think they still do that, where there's kings and princes and sons and a bunch of weird laws about how the power of succession goes down, or like Game of Thrones. For ease of use by both humans and computers, it makes it very easy. One of the main reasons that we use trees is because it's so easy for computers to loop through an entire tree by using what's known as recursion, which we'll get to later. But it's a way to essentially explore the tree, gather all the information you need without too much struggle. It had its origins in SGML, Standard Generalized Markup Language, from the 1980s. Considering I don't know what this is, I'm assuming it went out of date pretty quickly. And it became a standard in the late 1990s. So a lot of web pages will have XML feeds or will have XML documents. It's kind of like JSON as well, or HTML. All of this is just hierarchical data that is very easy for computers to understand. And we impose strict restrictions on how we store the data in XML for the computers so that they don't have to do things like check to make sure that you've actually formatted the document correctly. You assume, I guess in this case, that the XML is formatted. So what does XML actually look like? Well, it looks a lot like HTML. Here's an example XML document file. It starts with this XML version, which we never really have to worry about. Not part of the actual XML tree, but then you have a series of tags and attributes and a bunch of other terminology that we have to go over today. It's a lot of terminology today. I apologize on this Tuesday morning, but this is what an XML document looks like. So we begin with this XML declaration, which is the first line of a well-formed XML file, fairly irrelevant to what we talk about in terms of XML. I don't know. I'm going to be honest. I looked at this slide this morning. I don't know what this means. I think this is wrong. This is part of the document and file. I don't know why it's there. So we're skipping that slide. Okay. This is an author element. So an element can be composed of what are known as a tag and then content. So an element just means something contained within a tag. Both a tag and then optionally you can have content. So similarly to the way that we talk about HTML tags, we can have XML tags. And the combination of an XML tag and content, if it has it, will be this element. So we say that this is the author element, or this is the title element, or this is the book element, so on and so forth. This is the start tag for an author element. So each tag is going to have a start tag. And does anybody want to guess what this is called? End tag. And stuff that's contained within the start and the end tag are known as the content of that tag. end tag for the author element. The content for this author element is everything between its start and end. Content is. Now, this is optional. You do not have to have content between two tags. You can have just an empty tag. I think, yeah, so the book tag does not have any content. It has what are known as attributes, which we'll talk about later. But there's no content. There's no actual text that's linked to the book tag, at least in this document. So if the author element had no content, in the sense that we did not include an author, you can also have a self-closing tag, which is just the singular tag followed by, I believe, a backslash. And that's essentially, or syntactically the same as this. Questions so far? Yeah.
What's the point of even having if you're not putting?
Because computers. So if you're writing a program that says, let's say we're writing a program for Thomson, which is going to catalog all of their books. We want the ability to have an author tag for all of our different books. So like, let's say you had a program that was checking all of these books, and you said, okay, well then grab the author if it exists. If the author didn't even exist, then it would cause problems. So it's like a placeholder, basically. Okay, and then this is a title element, which is, I believe, the book for this class, the one that we have 3 of for the entire computer science department, or you can find online, which you shouldn't do because that's illegal. Wink, wink, nudge, nudge. Okay, this is a book element. So you'll notice we're starting to think of this, or we're starting to see similarities between trees and the fact that they're hierarchical and recursive. So within the book element, you can have an author element, you can have a title element, and so on and so forth. And a little bit of a spoiler, but this is the way that we are able to store XML documents as trees, is through this hierarchical structure. So the book element is going to have an author element, a title element within it. Okay, so when you have a tag, which has, before it closes, the starting tag has an attribute. We say that it's the name of an attribute, and then the attribute can have a value. So in this case, book has an attribute named print ISBN, which has a very long number. And then it has a web ISBN attribute, and then it has a pub date ISBN, or a pub date attribute. They don't have to have this. If you look at title doesn't have any attributes. Author doesn't have any attributes, but you could. So you could say that author had a genre attribute, which was CS books, if you really wanted to. Okay. And then that's the value. So it's the attribute name and then the attribute value. Okay. And then again, we have this recursive structure. So an XML document without the declaration at the top line is made up of a top level element and then a string of 0 or more child elements of the top level element, each of which is exactly like the top level element of an XML document. It's the same exact thing as a tree. The structure of an XML document is also recursive, and the information it represents is hierarchical. So it just makes sense that there's a way to store XML documents within trees. And it's known as XMLTrees. So spoiler for 37 seconds from now when we start that slide deck. Oh, wait, no, we have to do this first. Okay. So there's a few errors within the XML document that is on the screen now. So we are going to try to find the errors based on everything that we just talked about. So who wants to point out one of the errors here? Yeah. Exactly. So if you open a tag, you must close it. That is the first one. I believe there's 3. Yeah. Yes. So once you open a tag, you have to make sure that they are closed within the same order that they are opened in. So you cannot open a unicorn tag and then open a color tag and then close the unicorn tag. You must first close the color tag and then close the unicorn tag. Okay, and then the last one is a little bit hard, but it has to do with this dragon tag. Yeah. Yeah, exactly. So this dragon tag should be contained within the pony tag because if not, then it's a separate XML tree. It's not contained within the XML tree. Okay, cool. I think that's all of them. I think. Yeah. Okay. And then we have resources if you would like to look at that. And then you could look at the Wikipedia page for XML if you want to see how it is used or read a brief history of it. Questions on XML? Yeah.
So where should dragon go?
Dragon would go above this closing pony tag.
Okay.
That way everything's contained within the XML tree. Otherwise, you have this pony XML tree and then you have this dragon XML tree. And it's not a singular XML document. It's two separate ones. So you would need this line right here again. And it would also probably need to be in a separate file. Okay, questions on trees or XML documents before we combine the two? It's going to be awesome. Okay. So now that we've gone over trees and we've gone over XML documents, and my PDF wants to load, we will talk about the XML tree model. So we have this mathematical way to represent hierarchical data, which is trees. And then we have this XML concept, which is a way to represent or a way to store hierarchical data. So how you will use that is this module known as XML tree. So this is a component within Java. So think simple writer, simple reader. And then this is the third one, I guess, that we're talking about, which is XML tree. XML tree is a class. So class, remember, is this blue rectangle, which means it has a bunch of methods that you can use or functions that you can use to manipulate, modulate, look through, do stats on the XML tree if you would like. You'll get a lot of practice with that. Okay. So the XML tree component family allows you to create, navigate through a tree structure, which mirrors that of an XML file. The file from which the tree is created may come from your computer or may come from the web. So two different ways that you can create an XML file in Java is you can provide it a well-formed XML document. So this is not a well-formed XML document, but this would be. So you can provide the file name. Let's say that this is stored in XML.txt. You can provide that to a XML tree component, similar to the way that you could provide a file name to a simple reader, or you can give it a web link, which contains a well-formatted XML document. So there are web links online which have XML documents. I believe you use one in lab tomorrow, which just has a bunch of weather reports. So you can pass that link in and get a well-formed XML tree. You need not worry about parsing the file, so recognizing if there are tags, matching start and end tags, identifying attributes, as this is done for you by the XML tree class, the constructor. So if you pass it in a unwell-formed XML document, Java will yell at you and say, hey, you're trying to make an XML tree, but this is not an XML document, so I'm going to crash now. Good so far? Cool. So here's another example XML file, one which is an expansion of the XML document that we looked at in the last slide deck, where we have a book element, it has an author element, a title element, this contents element, this open, close, preface elements, and then a bunch of chapters, so on and so forth. This is an example of ways that you could store information online. So if you had a library database that you were trying to build up, you could store everything in an XML file. And then you could write a program that retrieves all the information through this XML tree component that we're talking about. Okay, here is a picture of the example XML tree that is created. You'll notice it looks very similar to the trees that we talked about earlier, except now the nodes are going to be element tags. So each element has its own tag. And there are restrictions on what you can and cannot have in these tags, and what the children of the tags are going to be, as well as the types of the attributes and all this other good stuff. I believe there's a very good slide that has all of the information that you will need for a project that is coming up, where you will explore XML trees. Okay, so the top level element, which is known as the root of the tree, is a book element. It has three of these things. Does somebody want to remind me what these are called? Yeah. And attributes have values, right? So this has three attributes with three different values. You'll notice that all of the values in a XML tree are strings. That is something that you must remember because people often forget that. So even if I had a book which had an attribute called like, I don't know, num readers equals 3. Even if this is how it was represented in the XML document, both num readers and 3 are of type string when you're using them in XML tree. That was a question on an exam. Was what is the type of something something? And everything is a string. Everything's a string, at least in Java. Okay, so you have the book tag, which you can see goes right here. In this case, it's drawn in a little nice picture tag. You will have to draw XML documents or XML trees based on both, or based on given something like this, something very, so what I'm looking for, much simpler than this, but you will be given documents that look like this and be asked to draw the resulting XML tree. So something that looks like this. Okay, so you have the book tag, which in this case we can just, we don't need to draw on the board, but any and all attributes that are of that tag get stored within the actual tag element underneath the tag. So in this case, we have a book and we have the 3 attributes which are described right below it. This is a tag as opposed to a content node, which we'll get later, which does not have a content node is not going to have this tag picture because content nodes are not tags. All of the attributes are stored there. And you can draw them either with an equal sign or an arrow. The attribute name value pairs of an element / tag are in the tree node of that element or tag. So they are stored within the tag of which they are linked to. And then you can see that this book tag has other elements within it. So we have children of that book tag. So the children of the top level element or tag are the children of the root of the tree. So in this case, it looks like the book has 3 children. It looks like it has an author tag, a title tag, and then a contents tag, which are all children of the book node. And then this author tag is in and of itself its own XML tree. This title tag is in and of itself its own XML tree, and so on and so forth. What this means is we'll talk about the methods that you use to create, modify, and look at attributes of an XML tree. But one of that is children. If you have an XML tree X equals new XML tree 1, and then we pass in, say, this foo.txt file, which is just a well-formed XML tree. You can make a new XML tree. XML tree Y equals x.child, I think it is, 0. And what this does is it makes an entirely new XML tree, same as the one that is generated via the foo.txt file, but also has all of the methods that you can use on the child. So in this case, it would be just an XML tree that's rooted at the author tag. And you'll use this a lot to traverse through trees and either print out information or count information about all of the children of all of the children of all of the children of an XML tree. Yeah.
Is the author and the title like not part of that same tag? Like,
because they're separate elements. So within the book tag is 3 different elements, which are in and of themselves their own. Another tag contained within a tag tells you that this needs to be its own separate child, its own separate root of an XML tree. If there was just, let's say, the text like hello, that would be a content node, and you would have another branch off of this, which was just content nodes look like this, which is just text. Okay, so that's the root node. Okay, so the first child, again, we index starting at 0. So this is child 0 because children are numbered from 0. And then you have the second child node, which is known as child 1 because we index at 0. And then the third child node of the root is known as child 2 because we index at 0. So when you're indexing, think of whatever child it actually is minus 1. So if you're thinking about the first child, think about it in terms of 0. So I'm like the youngest of 4, so I would technically be the 3rd child, even though I'm the 4th child. So you have to subtract 1. If you're an only child, you're the 0th child, so I apologize. Okay, so the first child element or the first child node is this author tag. You'll notice that there's content contained within the author tag. We separate these out. This is very important. So an author tag has a child contained within it, which just contains the content. So if we had a self-closing tag, like, let's just say we had like just say that we had a hello tag, that's a self-closing, it would just look like this. Would not have any children, but because we have content within the author tag, it gets a child, and the text that's contained within the tag or the content is its own node, which is known as a content node, different from a tag node. Separate those two out in your mind. Content node, tag node, different. This is the tag node. This is the content node. The content of an element is in a child node of the node for that element or tag. The content node itself has no tag. So there's a method to get the tag of a certain XML tree. If you try to do that on a content node, you will get an error because it's not a tag. Okay, the second child also has both a tag node and a content node. This time, the tag is called title, and the content is Java for everyone, late objects. So again, tag node, content node, and so on and so forth. The same rules apply for all levels of the XML file and of the XML tree object that's created from it. So you can see the first child of, let's get an example here. The first child of this contents node is in and of itself its own tree, which is just a preface tag. So in this case, it looks like preface is a self-closing tag. So that's what that looks like, which doesn't have any content. You have a chapter tag, which has 2 attributes and then a bunch of children. And then you have a chapter tag, which has, again, a bunch of children. So you'll notice that you can have duplicates of different types of tags. So you can have multiple chapters or multiple chapter nodes within a same tree. What separates them out is these attributes, this number 1, number 2, title. And then it looks like within the chapter nodes, there are also section nodes or multiple section nodes. So if you're thinking about like an XML weather report, you might have a bunch of different days. And each day is going to have different weather, but they're all day tags. Cool with that? Okay, reality check. That's funny. Okay, carefully examine. Oh wait, I skipped it. Oh wait, I skipped a lot of slides. Okay. Key properties or invariants. This is tough to note down. Every node in the tree represents either a tag or the text content. So K horsemen of an element. Every node in the tree has a label string that is either the tag name itself, author, or the text contained within itself. So I said that every node could be either a tag or a content node. Both of them are going to have this attribute called label that you can get. In the case where it is a self-closing tag, I don't know why I erased that. I actually need that. That just has the hello tag within it. The label in this case is just hello. But if we had a tag which actually had some content, so let's say hi, even. In this case, you would have a tag which was hi, And then you would have a content node below, which is Stephen. In this case, there would be two separate labels. So this tag node would have a label of hi. And then this content node would have a label of Stephen. So depending on the type of node which you're looking at, the label will be different. Only tag nodes can have 0 or more attribute name value pairs, each of which is a string. So you cannot have attributes of a content node. You can only have attributes contained within tag nodes. Good with that. Some key things to remember. And then everything's a string. Everything's a string. All of the attribute key value pairs are strings. Okay, so we have tag nodes, and then we have text nodes. Label, no attribute. Tag node with attributes. Okay, reality check. Carefully examine the example XML file and the example XML tree diagram shown earlier to check your understanding of how the file content is modeled by the tree. All right, so we're going to have an example here. Who wants to tell me what the root node of this XML tree is going to look like? Please raise your hand. We will wait. Yeah. Okay. Okay, cool. So I'm going to draw this. Should it have a tag? Yeah. Okay. Yes. So should it? Yeah. Okay, cool. Sorry, my bad. Okay. So it has a tag. So Buckeye. Okay. What's the next thing that we should do? Yeah.
Child node of location statement.
Cool. So the first thing is a child node. Should this have a tag in it? Yes. Good. All right. So this has a tag, and what should the tag be named, or what should be in the tag?
Location statement. Or we go, wait.
Yes, you got a 1 in 3 chance. Location stadium together or no? Location stadium or location stadium? Is there a pause or no?
Location statement.
Okay, try again.
Location space statement.
Okay, try to get home? No books. Okay, I guess there's more. Okay. Tags are always going to be the first thing within the carrots. So just location. We got that. Okay. Okay, now there's something else about this node that we have to do. Somebody tell me what it is. Yeah. Cool. And what should the attribute and value be? Perfect. Yeah. So location has an attribute, stadium, which is equal to. Okay. What's the next thing that we should do? Somebody who's not answered yet. Yes.
The content search box.
Yeah. So it should be another child. This is a content node, and you're saying it should not have a tag? Right, because it's a content node, and it'll just say Go Bucks. Okay, what's the next thing that we should do? Yes.
I had a question. Is think Go Bucks must be a child of Buckeyes or is it a child of location?
Oh my God, you're so right. That was a test. I was testing all of you, and you're the only person that passed. Okay, this should actually be a child of, I forgot that. So location in this case is a self-closing tag, which means it's not going to have any children. So this should actually be a child of the Buckeyes tag. Congratulations, you have passed. Everybody else, go home. Think about how you have failed today. I'm joking. Okay. Now that we've passed that test, okay, we're gonna slow down. Okay, what's the next thing that should happen? Yes.
You have another tag from Buckeyes for James.
Right. Right. Okay. And should this be a tag or just a content node?
Tag.
Tag. Okay. Called game. And what else?
You have attribute for op and then a value for UA
And then,
and another attribute for date. And then the value for 22 September 2012.
perfect. So you have two attributes in this case. You have an op, which is UAB, and then you have a date, which is 22 September 2012. That is a long time ago. And then our tag needs to be bigger because I forgot how to draw. Okay. What next? Last one, yeah. For test tag, which should be child of what? Nice. Okay. Then we have forecast. You're saying it should be a tag.
Yeah.
Forecast. And then what's the final thing that we need to do? Yeah.
Content. Forecast.
And then what should the label of content be?
Person.
Nice. Okay, we got there. I think this is great. Is there anything else we need to do, or do we think we're good? Going once? Going twice? Answer key. There's not an answer key? Okay, I think this is right. You would think that there's an answer key, but there's not. But yeah, that is how you go from XML document to XML tree. I'm not gonna say it's fun, but it's not boring. You'll have to do it eventually. So if you did not raise your hand today, you cannot escape drawing XML trees. You will have to do it. So dread it, run from it. XML trees still arrive. And okay, I guess class is over. Have a good one. I'll see you tomorrow. Yeah. If I can find it, I might have exited out of it. Just kidding. Hey,
I just wanted to ask about project 2.
Okay.
I forgot to attach the PDFs, but I attached the zip file. So is there any way that I could like add the PDFs down, get some of the points back?
yeah, just add them now.
Okay, thank you.
And then Slack message me because I'll forget.
What?
And then just Slack message me that you
Okay.
did that and I'll because
Thank
I'll
you.
forget. Yeah, have a good one.
I just have a quick question.
Yeah.
About the difference between elements and attributes.
Sure.
So, element is a different like little box in itself, and attributes are like the part of that.
Elements is everything contained with the tag and below it. So this is a game element.
So like, yeah, I was confused about this part because forecast had sun in it, so
Mhm.
that's like a whole another like
Yes.
part.
So forecast is also an element. So
Uh-huh.
game has a forecast element within it,
Uh,
but forecast in and of itself
It
is
has
its
its
own
own
element.
Got it.
And the forecast element has content, which is.
Alright. And yeah, got it. Sorry, figured it out.
Yep, and then these are attributes and values.
Yeah, I have. Also, one other thing about grading.
Mhm.
So for all of the projects that I had submitted earlier,
Yeah.
all of them are zero currently.
Right, because I need to go in and,
Yeah, I was just gonna like ask you about that.
yep, Slack message me so that I do not forget, and I will do
Okay,
that
got it.
today after my class.
Yeah, it's fine. Yeah, I just wanted to.
Okay, yeah.
Yeah.
Right. Don't worry, I won't let you just keep them at zero.
Yeah, I just like wanted feedback so that I could like.
Yeah.
figure out stuff.
Mhm. I'll get them done today.
Thank you so much.
Yeah.
I have two questions. Are we not allowed to like use ternary operators in projects?
Use what?
Like the question mark operator,
Tertiary operators?
Yeah,
You can use tertiary operators.
because it flags the.
Oh, it does, really?
Yeah, it does. But is it like fine? I did it in the homework, but can I do it in the?
I would check, let me check the best practices document.
It flags that we cannot use a len code or something like that.
What's the actual error message?
We cannot use okay, let me check it right now.
long as it's not in. Oh, yeah, so it's flagging it just because it's not part of the best practices document for some reason.
Yeah, to avoid.
Yeah, so number 15 on the best practices is not to use the tertiary operator, unfortunately.
So do I have to not use it?
I would not use it in projects.
And
Yep.
for the third project. You know, they don't do this one. So
Yeah.
Can I do it like with this one?
Yeah.
Like I will. Now I will just only make one program, but it will ask the user which one do they want to do the inputs for the inputs of file.
Wait, sorry, what was the question again?
For example, I will like program it that it will ask the user whether they want to do the whether they want to have like 3 inputs, 4 inputs of.
Yeah,
I can do that, right?
yeah, just make it in a separate file from the ones that you're asked to create. That one, so that it separates out from like the normal project and then the additional activities.